Hi, I'm Nadya and I'm presenting Nothing Like Compilation, how professional digital fabrication workflows go beyond extruding, milling, and machines on behalf of Mare, Hirsch, Gabrielle, Benabdallah, Jennifer Jacobs, and myself. This was published in Tokai and is presented here at CHI 2024. Digital fabrication research is of increasing interest at HCI. Yet it focuses predominantly on the needs of novices. And how do these tools that are being developed, which focus on novices, especially the ones that prioritize computation, align with the needs of contemporary practitioners? We wanted to understand professionals who use digital fabrication now in their practice. And to do so, we studied groups of people who developed 9 specific products using a variety of different types of digital fabrication, including CNC milling, 3D printing, and other computer-controlled processes with materials ranging from aluminum, as shown here, to porcelain, to textile, or plastics. I'm not going to cover all of them now, but I will highlight 3 of these products to understand their complexity in this talk. The first of them is the Coral Cup by Nervous System. The Coral Cup is made of slip-cast porcelain, which is glazed, and Nervous System designed these cups using their own implementation of reaction diffusion. They used that software to be able to create the organic ridges that they would iterate on to create different textures, and finally selecting one to create a form that then they 3D printed a mold for, which they cast a rubber mold in, which they then cast the plaster molds in, which they then cast their cups in. The second is the Corai table, which is designed by, which was released by Roche-Beaubois, the French furniture company, was designed by Fritsch and Durasati, and was produced by the French concrete 3D printing company Extruding. The users, any customers of the table could purchase it by customizing their tables through a web app provided by Roche-Beaubois, where they could specify the textures that would be assigned to different parts of the table, the size of the base, the size of the tabletop, and the overall shape and dimension within the parameters of what could be 3D printed by Xtree in their concrete 3D printing facility at large scale. Finally, the third example is Astus, a wooden vase made by ODK Design, which is made out of robotically milled beech plywood. The undulating lines stem from the programmed tool paths that the robot took with a specialty end mill, and they were finished by hand by professional woodworkers after coming off the machine. The initial form of it was laser cut, stacked, and then milled to minimize robot cutting time. These 3 products, the Coral Cup, the Corai table, and Astus, demonstrate some of the different material and process dimensions that we studied when looking at these digital fabrication processes. Some of them use digital fabrication as the method to complete a final product, 3D printing things directly. And whereas in others, digital fabrication was used in part of the manufacturing process, for example, to create the tooling necessary for a mold, or to be able to specify other components of the design that would later be fabricated in other ways. What we found was that there were several surprising elements to take away from how people were behaving with digital fabrication. Rather than trying to simulate everything digitally first and then produce it, we found that the designers were relying on multiple partial and ambiguous representations to be able to design their products. Nervous System, when designing their cup, did not 3D print lots of iterations of their cup. Rather, they relied on images that they produced, imagining the 3D elements themselves. The manufacturing workflows, however, that they relied on were critical for them to prototype. People developed robust product-specific manufacturing workflows where digital parameters and physical constraints were iterated on to establish the design space they could work in. For example, the glazing processes of the porcelain cups, or the 3D printing tool pathing choices that enabled the 3D printing with the textures that were desired. And we found that rather than thinking that tool paths or G-code was just something on the way towards the final product, the machine tool paths themselves actually were often the design choices. The step over of an end mill, creating the undulating ridges in a cup, and the path that the tool took in general, specifying the geometry, something that otherwise would never be seen in CAD. Based on our findings, we have arguments for how HCI systems development should go forward in supporting digital fabrication systems. Parametric design should support the exploration of geometry, machine settings, material behavior, and the interdependence of all these three, as we saw our participants do. It is not the case that just with an STL you can reproduce some of the 3D prints, even though you'd think that would be sufficient information, or it is implied. Process prototyping itself and understanding how to control interdependent parts is critical. The simulation of this is not. We saw that our participants regularly did not use any kind of digital representation of the products that they were producing, and would rather rely on their own imagination for things that were easy for them to understand, and on testing for experimental processes and other material qualities that were not. And finally, we argue that material constraints and resource management are design dimensions that HCI systems research needs to support for digital fabrication, not realities that should be flattened or optimized or seamlessly worked away. Understanding time, cost, the possibilities of the material, and the possibilities of the machines is what makes up the design space that we saw our participants explore and exploit in creating their products. We'd like to thank all of the participants that participated in our research. We encourage you to see the other products that are included in our paper. And again, this was nothing like Compilation: How Professional Digital Fabrication Workflows Go Beyond Extruding, Milling, and Machines by Mare Hirsch, Gabrielle, Benabdallah, Jennifer Jacobs, and Nadya.